All right, here we go. The next one. It's sort of fun for me. I'm really enjoying this and I'm learning a lot, and really gets me thinking about my own teaching. So today I think I did a Google search for homework 2 solution or something, and it found this one, which is homework 4.3.6 solution for number 2. So here we go.
Hi Cougars, welcome to this video. We are going to work a 7-step problems from homework 4.3.6. We're going to work this one, and then in a separate video I'll work number 3. So number 2.
So the idea of putting things in a separate video, I really like. In certain learning management systems, you can put little direct links to 5 minutes in or something, but I don't know. I think I like separate videos for these things. So I think that the way he's doing that makes sense to me.
John decides to use a conveyor belt system the next time. The power used in this next time was 20 watts for 1,000 seconds. So the seconds carries to the next line. How much work was done by the conveyor belt?
So I love that work is capitalized there. Did you hear how he said it? How much work? It's like he's driving home what needs to be done. Capitalizing it is interesting too, because I think it helps the students sort of find it in the problem. I guess I don't know. I don't know if I've ever seen it capitalized like that before. Very cool.
Okay, so our conveyor belt basically is almost like an escalator, but it usually moves packages or something from side to side.
Nice.
Box moving, and the conveyor belt is using a power, or outputting a power of 20 watts, and it's running for a time equal to 1,000 seconds, and we're wanting to know.
So the idea of rewriting the information right next to the drawing, right? It's just right up here. And in fact, he already circled it. But I think it's really, really interesting to really sort of say out loud what it is we're doing, and by putting it in proximity to the drawing, I think is helpful. Like, look, this is the thing that has the power, and this is the thing that's going to be on for 1,000 seconds. I also think it's interesting that he drew the conveyor belt horizontal. It sounds like this is the second problem of a series. Certainly if it's a vertical conveyor belt, I think that this, some other things could happen, because suddenly you'd have different forces you'd have to worry about. But I'm wondering if he's even going to talk about the gravity and normal canceling each other out. It's interesting, right? Because sometimes you can do that to be super thorough and talk about the full free body diagram and say, oh, well, it's not even moving in the vertical direction at all. So notice, please, that these two forces cancel before jumping into the rest of the problem. Or you can just sort of jump in and do some stuff. Now, this isn't really a force problem. It's more of a, work problem, I guess. Well, yeah, capital W work problem. So I think very, very likely he's not going to do that, but let's see.
Know what's the work being done. Okay, so that's our general picture.
It's interesting. I guess it doesn't matter what orientation the conveyor belt is in, because work done by the conveyor belt, well, if you know how much power is being fed to it, that's it. That's the whole story. And maybe, there's some friction, or maybe there's somebody yanking on it, or maybe it's vertical, or maybe there's gravity. But the fact is, somebody's feeding it some power. And so this problem, I guess it really doesn't matter what orientation the conveyor belt is. So what I wonder is, what's best for students, right? To just assume, oh, it's horizontal, don't worry about that other stuff. Or to talk about the fact that who cares what orientation is? I'm curious what you think in the comments. I think, he's drawn it horizontal, so we'll see how it goes.
Let's go ahead and do our guess. So we've done our R2, we've read twice.
Oh my. I love this. Seems like this is from some sort of way of approaching problems, but to start with a guess. Fantastic. Fantastic. So, there's not a whole lot here, so I'm curious to see if the guest just kind of gets the whole answer done. But, man, yeah, love it.
Now we're doing our draw twice, now we're doing our guess. So givens, we've got power equals 20 watts. Time equal 1,000 seconds. Unknown is work.
So this is now the third time this information is on the screen, right? So the problem, I had the drawing, and now in this guess feature, he's writing it again. So it reminds me a little bit of sixth grade algebra. At the very end of the year in my sixth grade, we decided to do a little bit of algebra. And I ended up really being frustrated with it because we had to write every single step down. And if you reverse the order of a couple of numbers, you had to say, oh, that's because of the the commutative property of multiplication. You couldn't just do some quick algebraic steps. And so I got really frustrated with it. But I'm really, really intrigued by teachers who help students understand, look, this is a process, and you really want to have all of your information in place. It reminds me of when I'm doing, little projects, whether it's in the lab or at home. If I have all my tools together and I'm ready to go, then it's easy. Same with cooking. I finally have decided. And I think my wife is probably laughing that it's taken me so long to figure this out. But I finally decided to get all my ingredients ready before I turn on the heat. I used to, quickly turn on the rice and then, okay, let's go chop some things up. And then, wait a minute, I don't have enough time. And so when I have all the ingredients ready for me to go, all in one place and very clear, I even usually put it in the order that the recipe calls for. It just kind of helps me be prepared. And so this idea of rewriting it yet again, because over here we're making our guess and we need to know what's given and what the unknowns are. I think that's really cool.
Equals question mark. And now I'm going to select an equation. So our equation is going to be something that should have power, time, and work all in the same equation. And if you look on your equation sheet, you will see power equals work divided by time.
So people talk a lot about, the value of equation sheets. And so he's saying, okay, these are the three things that we have connected. And let's go see if we have a relationship among them. And oh boy, here's one, right? And it's really, really interesting. I love the fact that this particular problem isn't built to calculate power. Because if it's built to calculate power, well, you take the work, you put in the time, you're done. But obviously, a tiny little bit of algebra needs to get done here to figure out what the work is. So I think that the idea of an equation sheet is fascinating because at times students really get caught up in just not even trying to understand the problem. They'll just search for stuff like crazy on it and try to find P's and W's and T's in there. But I think that if you really sort of coach them to understand, okay, look, we've thrown a lot at you. We want you to remember the relationships among things. But there's some stuff like factors of 2 and pi that, it's okay if you forget about.
Now I'm going to substitute. Be careful when you substitute. Make sure you're following what the variables over here say in your table. So power is 20 watts. So I'm going to substitute that for that. Equals. Do I know my work? I do not know the work. So
What was he going to put a question mark? Oh, the W. Question mark would have been cool.
Yes, I do know the time. So I'm going to plug in that number. 1,000 seconds.
Interesting that he's using parentheses.
Okay.
That's fascinating. I mean, so from an algebraic perspective, he doesn't need the parentheses. There's nothing else on this left-hand side that really needs to be sort of grouped apart or anything like that. And same with this denominator down here. But I have a sneaky suspicion that this is connected to students using their calculators. And so definitely with denominators, I don't think it's a bad idea at all to use parentheses, because if you have, a divided by b plus c or a divided by b times c, that denominator, if they just punch it in the calculator like it reads, of course, the denominator gets screwed up if you don't group the b and the c in your denominator. So I'm curious if where this parentheses comes from is to help them with their calculators. That's really, really interesting. It's subtle, right? I mean, it's a scaffolding that what does it mean to take that scaffolding away eventually? But I think that sometimes the algebra and the math scaffolding we provide students, I think I'm okay with it staying a lot longer if it can lead you to deeper conversations about the physics, eventually.
And now we're going to do our algebra now that we've got it substituted. So to do our algebra to help us decide what's moving and what is going to stay where it's at, I always go back to what are we looking for? We're looking for watts. So we want this to be watts equals some number over here. Okay.
Boy, that was really interesting, just that last little piece, right? So he said some number over here, and it was on the left-hand side. And I think that I love teachers who who work with students to understand the flexibility of equations, right? So you can have some stuff over here, you can have some stuff over here. You can move stuff around all you want. I think that it's interesting that he seems to be okay at the moment of having the unknown staying on the right-hand side and the answer on the left-hand side, which feels backwards from typically how we might encourage students to put their answer eventually. But I think it's great that he's not really showing much preference for the sides or priority for the sides.
So to do that, that means I'm actually going to have to move the 1000. So just so we have room, I'm going to read.
So before he writes this, I'm reminded of how some, usually not teachers, these are more like sort of YouTube channel people, when they say things like, I'm going to move the 1000, sometimes people will literally grab it and move it, right? Like over here. And what tends to happen is, notice over here we have a fraction. And this line is roughly vertically spaced with the equal sign. So if you move the 1000, first of all, the line stays there, which looks funny, right? And the W doesn't seem quite right. It doesn't seem aligned with this equal sign. And so I think that taking the opportunity to rewrite it is good, but it kind of depends. Like, are you sort of teaching, or are you really encouraging, showing students how to do this step by step? So I'm intrigued if there's any of you who literally move things, how that helps your students, because I really want to know about that, because obviously we have the tools to do it. You use the lasso, and you drag it over here, make sure to make those sound effects, and you're good to go.
Rewrite and show my work. You should show your work. We're going to multiply both sides times 1000 equals 20 times 1000. So 1000 divided by...
Interesting. That was really sort of interesting, his use of parentheses, right? So here he put it in parentheses to make it very clear that it was separate from the fraction. Over here, he already had something in parentheses, so he just kind of wrote this over here next to it. So there could definitely be parentheses overkill, right? I mean, calculators don't mind. You can put a whole bunch in. But I gotta say, visually, this looks great. It's very clear there's two things over here, and it's incredibly clear that there's a fraction and then something, right? So that's pretty interesting. I'm also curious what you folks think about putting this over 1, so that it's definitely two fractions being multiplied by each other. I see that a lot in my kids' homework. And for me, it's all about clarity. Like, how do you convince students that this is an okay thing to do?
Equals 1, and we say it cancels. 1 times W equals W.
Awesome.
We've got our work. And then 1000 times 20 is 20,000.
Oh, I wondered if he was going to put the comma in.
So the unit...
This comma is so interesting, right? Because it absolutely helps our vision. There's the reason for it, right? And yet on calculators, there's not really a comma. I've noticed in Python, I think it was Python, you can use the underscore for a comma. I tell you, with big numbers, it sure makes it easy to read. In Mathematica, after you type a gigantic number, it does a tiny little bit of spacing for you. And if the output is a number, you can get Mathematica to put the commas in. But let's recognize the power of typesetting, right? The comma's there for a reason. It really helps people keep track of their zeros.
Units must be in joules. So we've substituted, we have our solution, so we've done the whole problem.
So I've talked about this before, this idea of the metric system kind of being trustworthy, right? Well, let's see. We had power and we had time, power in watts, time in seconds. Those are the two of the allowed units. There's no kilos in there. There's no micros in there. There's no weirdo English units in there. And so you can just trust that if you're going to do whatever your equation says, that your answer will be in the right units for work, which, look it up, oh, that's joules, right? I mean, technically all this problem has is watts times seconds, right? Technically, if you just sort of keep it together, it's watts times seconds. But to trust that it's in joules, I don't know, I find that to be comforting, but I'm curious whether people think, oh wait, first it's watts times seconds, and then, a watt is a joule per second, and then the seconds cancel, we're left with joules. Like, what is the value of that? compared to just to the trust feature of, hey, we're the metric system, it's going to work out. So I'm curious what people think about that.
If at any time I want to check my work,
Ooh, I like
need
this.
to take my answer and plug it back into the equation
Oh, awesome.
and see if it checks out. If I
Awesome.
did the math wrong. So if 20,000 joules is the work, and I divide that by 100 or 1,000 seconds,
Now see right here, I do a terrible shortcut, right? I just cancel these zeros, check, 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 and then cancel 3 zeros, check, 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 as opposed to doing this, right? Really making it clear. And so as I'm watching this, this is a problem that is, it's pretty straightforward, right? I mean, you read the problem, you're like, oh, boom, multiply, done, right? I mean, I could imagine that some students were just like, well, here's your answer. In fact, those students are going to be frustrated by this 5 or 6 step, maybe you called it the 7-step process. But the consistency, the attention that he's paying to this to really show that, look, even for a problem that you just go multiply 2 numbers, our system can work. You can trust the system. And if you are feeling like you're ever thrown in super deep in the pool, go back to your system, right? And okay, what can we do? What can we do? And so I think that's super useful.
then my answer should be, plug it in your calculator to make sure, should be 20 watts. So you can always double check your answer by
That's awesome.
doing a reverse plug in the numbers.
That's awesome.
Okay? But that is number 2.
All right. Well, thanks everybody. You can tell that I'm morphing. Obviously, I'm super excited to see these fantastic teachers work so hard to help their students, and I'm loving it. I'm really having fun doing this. But you can see that I'm also just trying to learn, right? Like there's some approaches that I don't think there's a right answer, and I just want to hear more stories, right? Like, well, in that case, I would have just canceled the zeros, or I don't know, this is not maybe I wouldn't have done this as a 7-step problem, or holy cow, you have to do a 7-step problem. You have to do all 7 steps, or the students are really going to be flailing about. And so I want to learn more about that. So please feel free to let me know. Hope you all have a great day. Remember, teachers are awesome. Sorry, physics teachers are. Oh, okay, teachers are awesome, but physics teachers are awesome. Have a great one.